Welcome to physics, and we will be talking today in this class about chapter 18, section 1, fraction. If you've gotten a chance to look over the pages, I hope that you're able to see them. What we will be talking about is refraction. That's the bending of light as it goes from one type of substance into another, air into water, water into glass, etc. It goes like that. If you'll notice, a good example of refraction would be when you stick a pencil in a glass of water and you look and see how it's bent. What's happening is the light rays are bending as it enters a different medium. So refraction is what's happening there. If we were to have a surface, and let's just say that this is glass here, and up above we have air. What we draw here is a perpendicular. Remember, this is called a normal. As a ray of light passes from air into, let's just make this whole thing glass. Forget about that. This whole thing is a big pane of glass. What happens is, this is the incident angle. The incoming is called the incident. And what happens is it's going from a less dense into a more dense material. So the light will bend toward the normal. This is going to be theta sub r, or it's going to be the refracted ray. As it goes from less dense to more dense, the incident angle is going to be greater than the refracted angle. The opposite is true if it's going from a more dense into a less dense material. Say, for instance, this was water, and this is air. Here's our normal. Let's say it's going in here at an angle close to 45 degrees. As it goes from a more dense to a less dense, the angle is going to actually be increased. So theta r is going to be greater than theta I. Or if you want to put the opposite, theta I is less than theta r. So those are basically the rules. And we have an equation that we will be using, and it's from a scientist or a physicist named Snell. And it's called Snell's law, which states that the product of the index of refraction times the angle of incidence, or the first one, is equal to N2 R2. I'm sorry, I apologize for that. N2 sine theta 2. I misspoke, which will happen quite frequently, as you are aware. And every type of material has its own index of refraction. The index of refraction, for example, for air, put a little air down here, is 1. It doesn't have any unitless. Kind of like the coefficient of friction. That for water is 1.33. Most glasses, like crown glass, for example, they go between 1.4 and 1.5 because of their different densities. So we could probably just say 1.5. I think 1.52, a lot of them are. And your book has a chart that is on page 486. That actually has a table that has all the different values. Diamond seems to be diamond seems to bend light the most. You see all of the different colors of the rainbow when you look closely at a diamond, and that's 2.42. Again, they're unitless. So what I would like to do now is I would like to do the example problems that we have, and they are on page 487. We'll do a few of these, and then I'll assign you some to do. Page 487. I have to get there myself. 487. Example problems. I'm going to try and put these so that you can see them as we go. It's kind of hard to see there. If you have them in front of you that you can look at, or we'll just go along as we go. This again is page 487. Try and make it so that we can see this and see my work. It's a learning curve, people. It's a learning curve. And it's slippery slope. All right, the question number 1 says, a laser beam in air is incident, that means it's coming from the air, upon ethanol at an angle of incidence of 37 degrees. What is the angle of refraction? So the first thing we do is we're going to put air underneath number 1 is going to be air. I'm going to label that as 1. And 2, because this is incident, 2 I'm going to label as the ethanol. What's happening is we have air here, here's our normal, and it's going into ethanol. It is incident at an angle of 37 degrees, so this is about 37 degrees. Theta I is equal to 37 degrees. So since this is air, its index of refraction is 1. Theta 1, we are told, is going to be 37 degrees. Ethanol. Now, if I look up on page 486, I find ethanol to be 1.36. Its index of refraction is 1.36. The index of refractions tell us how much light will bend as it enters into that material. This is what we're looking for. We're looking for the refracted angle. Writing Snell's law again. Substituting in, I know this is 1. I actually don't need to put that there since I know that it's 1. My incident angle is 37 degrees and 2 is 1.36 sine of theta sub 2. So this is the part that we're looking for. I'm going to get sine theta all by itself, sine theta 2 by itself. I'm going to divide both sides. Now again, I don't need that 1 there. If it was a different type of material than air, then we would put that there. That's why I'm leaving it there, so just in case it was something different. Divided by 1.36. Now what's critical here is when you go to use your calculator, you need to be in degrees. So I'm going to get my calculator out here and I'm going to turn it on. And I'm going to show you how we do this again. Now, if you recall, I want theta, I don't want sine theta, so I have to take the inverse function. And if you look, that is right here. It's the sine inverse. So it's blue. I have to hit second to get that. Second sine inverse. Oops. And now I'm going to plug all of that in there. I have 1. Again, I don't need the 1, but if it was water, I'd put 1.33 there. Sine 37. End that parenthesis. You have to end that parenthesis. Otherwise, it won't do the order of operations that we're looking for. And we want to divide that by 1.36. And then I'm going to hit enter. My light's reflecting, I apologize. 26.3 degrees. So it's coming in at 37 degrees, and when it hits the ethanol, which is more dense, it bends toward the normal. And that angle right there is going to be the 26.3 degrees. And that's how you do that. Now remember, when we get to this, we're using second sine on our calculator. We want, oops, sine. I have the wrong sign. And actually it's just SNIN. We want this function right here on our calculator. So that's how you get that. Now, if I hadn't had it in, if I come back here and I look and I go to mode, you can see that I do have degrees highlighted. If I didn't have degrees highlighted, if I had radians highlighted, and I went to do this equation again, it's going to give me a negative, really weird value. So that tells me that I was not in degrees. So I need to be in degrees. Again, go to mode, go down there and choose degrees. Now I know in trig, you are using mostly radians, but remember in physics, we use mostly degrees. Okay, let's do number 2. Number 2. Now, I'll read this to you. I can't really get this to be in there, but number 2 says, light in air is instant upon a piece of crown glass. So we have air in the top, and we have crown glass below. Instant is what it's starting from. It's starting in air. So is instant upon a piece of crown glass at an angle of incidence of 45 degrees. So this is coming in at about 45 degrees. So that is, I'm going to put air here as 1, oops, air as 1 and 2 crown glass. Those will be the subscripts I use. Oops, you can't see that. Let's just completely forget about the book. I know you guys are getting frustrated with me. I apologize. Can sort of see. Well, let's just do that. Let me back out. Back out. There we go. Okay. The index of refraction for air is 1. For crown glass, I have to go to the chart. And the chart tells me it's 1.52. Theta 1 is actually 45 degrees. This is what we're looking for. Setting it up using Snell's law, again, using this one right here. If I set it up again, I get 1.00 sine of 45 degrees is equal to 1.52 sine of theta 2. And that's what we're looking for. We're actually looking for theta. Sine of theta 2, if I get that all by itself, is going to be 1 sine of 45. Again, you don't need the 1, but if it wasn't air we were incident, then it would have to, you would have to put that there. Divided by 1.52. So you get your calculator out. And you would hit the second sine button, or the second, and then you would plug in those values. I'm putting the 1 in there. And then sine. Oops, I put 1.11, didn't I? 0, 0. $45. Don't forget that has to end. You have to put that there. Otherwise, the order of operations is just completely screwed up. Divided by 1.52. Okay, so that tells me maybe I did not correct that. I want to look back there. That does not look like it's right. So I'm going to go to mode again and see if I changed it. I did change it. Oh, because I have sign. You see that? I have sign, not second sign. So what I have to do, go back here, is fix this and change this to second sign. Second sign. And now it'll be all right. 27.7. That's theta 2, not sine theta. Degrees, don't forget to put degrees there. So that's what happened there. It went from air to crown glass, and it really bent quite a bit. It went from 45 degrees to 27.7. So that's quite a bit of bending when it goes into the glass. Okay, I'm going to do one more for you. And we're not going to be incident with water this time. So what I'm going to do is I'm going to go to question number, which one do I want to do? Number 5. I do question number 5. That one's a little bit more challenging. Number 5 says, a block of unknown material is submerged in water. So basically what we have here is we have water as our incident, and then we have unknown material here. We don't know what that is. Light in the water is incident on the block at an angle of incidence of 31 degrees. So this is 31 degrees here between the normal and the ray coming in. That's the incident ray. And we'll just call it theta 1 is 31 degrees. So I'm going to have 1 be water. And I'm going to have 2 be the unknown. Water, I know what that index of refraction is, 1.33. This one, we don't know. They also tell us that the angle of refraction is 30, or no, this is 31. And this one is 27 degrees. Bends a little bit more, so it's going to have an index of refraction that would be higher than water. It's going to be higher than 1.33 because its angle is less. Because this angle is less than this one, it's being bent toward the normal, so its angle is going to be smaller. Using Snell's law, we substitute in what we know. This is going to be 1.33 sine of 31 degrees is equal to N2, don't know that one, times the sine of 27 degrees. Solve for N2. It's going to be 1.33 sine of 31 divided by sine of 27. Now, when you plug this in, you just have to plug in 1.33 times sine of 31, end your parentheses for the angle, and then divide by 27, and what you should get is 1.50. And if you look at the chart, it's some type of a glass. Crown glass is 1.52. It's pretty close to being a glass. I would say that that's what it is, some type of glass. Okay, couple other things I want to hit on. If you have air, move that up. If you have air and it goes into, let's say, water, for example, and then it goes back out into air. Low power mode. Gotta finish this in a hurry. Here's the normal here, and let's say that we are at, let's say we're at 45 degrees. When it goes into the water, it bends toward the normal because it's more dense, and then it comes down here. Now we've got a whole nother problem right here. Now this is the incident, and what's going to happen is this is going to go back out at the same angle. So whatever this angle was here is going to be the same as what this angle is here, because it corrects itself. As it goes through another material and comes back out through the original material, it will be going at the same angle. So if this was 45 degrees, this is also going to be 45 degrees as it comes out of that substance. I mean, it could go through 10 different things. If it's starting from air at 45 degrees angle and goes through glass, water, glass, back out, it's going to be at 45 degrees when it comes back through the air. Okay, so what I would like for you to do is I'm going to ask you to do, this is going to be your homework, page 487, 3 and 4. Those are the example problems. Very similar to what we just did. And I would like you to make an attempt on page 509. I would like you to do 67, 68, and 69. Give them a whirl. Basically, guys, what I'm correcting for is the attempt. I want to see you try it. Just give it a try. Do the best you can. If you have any questions, email me. I miss you guys an awful lot. What else was I going to say? There's something else I was going to say. When you get done with this, which this will not be due till Monday. Let's just have this due on Monday by midnight. If you would take a picture of it and just send it to me, to my email. I get your emails. You just sometimes don't get mine unless I put a G in your address. So we should be good. I would appreciate that. Just take a picture of your work. And if you have any questions, again, please contact me through email. Take care, guys.